Alrighty, we're on the last section now. Quadratic equations, the quadratic formula. This is kind of a way to skip some of the work. I was going to say cheat, but it's actually more complicated sometimes, so we're not going to say cheat. Well, never mind. Sometimes it is fitting to use the term cheating because I know how hard y'all work to cheat sometimes. All right, I'm just kidding. Anyway, so whenever we're talking about the quadratic formula, we are specifically referring to quadratic equations of the form ax squared plus bx plus c equals 0, where a, b, and c are the coefficients. They are real numbers. Okay, so typically they'll be nice, pretty numbers, but they could end up being fractions, theoretically speaking, but we're not going to be that mean as of right now. Okay, so anyway, if you have a quadratic equation in this form, then you can actually solve it bypassing all that factoring business by using the quadratic formula, which says x equals negative b plus or minus square root of b squared minus 4ac over 2a. And I don't like how close that fraction bar was to my minus sign, so I'm going to rewrite it. Okay, and so notice a couple of things. What this thing is not, right? It is not negative b plus or minus the square root of b squared minus 4ac and then the square root part over 2a, right? Don't give me that, because that's going to be wrong. It will not work for you. That fraction bar needs to extend all the way through, okay? So keep that in mind. All right. And yeah, it looks complicated, but it's really not. You have to look at it in isolated parts. For instance, this piece right here is called the discriminant. We'll talk about that a little bit more later on, but just kind of keep your eyes on that for now. Let's go to an example. It's always easier once you see an example. So, example 1. Negative 2y squared minus 8y equals 3. Okay, and I know we're talking about y here, but we had an x in the formula. That doesn't matter, right? The x is just a placeholder for any variable. It could be y, it could be z, it could be, I don't know, theta. I don't know, whatever. I got excited. Okay, so anyway, notice the first problem that we have here is that this is not in the right form, right? It's not in the same form as our standard quadratic equation. In other words, it's equal to 3. It's not equal to 0. So I need to take care of that first. I will subtract 3 from both sides in order to accomplish that goal. Do remember that this minus 3 right here, it's a constant, so I can't actually subtract it from either of these two terms. So I kind of have to leave it separate. Negative 2y squared minus 8y minus 3. Okay, keeping them separate. Also, you want to keep them in order of descending exponent power, right? So 2 understood 1, and then I don't have a y right here, right? So that's kind of like saying y to the 0 power. So you want to keep it in order. All right, and then here's something that is not an official step, but something that I like to do. I do not like having this first number be negative. It just makes it a little bit more complicated, so I'm going to take care of that by simply dividing all of my terms by negative 1. Right? Remember, you can do that as long as you do it to everything, especially both sides of the equal sign. All right, so that's going to clean this up a little bit. That's going to give me, screw this up a little bit, positive 2y squared, positive 8y, positive 3. Isn't that a little bit nicer? Right? A bunch of positive numbers. All right. So before we go any further, I want to use the quadratic formula. Remember, it says negative b plus or minus square root b squared minus 4ac all over 2a, right? All right, I want to identify a, b, and c. Remember the generic quadratic equation we had earlier? Says that a is attached to y squared. So in this case, a is 2. B is attached to y, so it's 8. C is the constant. So 2, 8, and 3. I'm going to go through and plug all those in to that quadratic equation. So y equals negative b plus or minus the square root, Okay, so b was 8, so put 8 in. Let's use a different color there. 8. All right. B squared minus 4 times A times C over 2 times A. And let me actually color code it a little bit better. Let me put B will be red. Let's say A is blue. A is 2. It goes there and there. And we'll say that C is pink. So C is 3. Put that there. All right, cool. Let's clean that up. Let me go ahead and move all this out the way, this unnecessary garbage. All right, so -8, we know what that is. It's -8. Okay, that took a lot of brain power. Then we go on to the square root part. 8 squared is 64. 4 times 2 is 8 times 3. It's going to be 24. Okay, so that's my square root part. 2 times 2 on the bottom is 4. And so 64 minus 24 is 40 over 4. Okay, see how it's getting a little bit nicer, a little bit neater. Okay, and not too long ago we talked about simplifying the square root of 40. Let me do that off to the side real quick. Let's take a purple detour here. Square root of 40. Well, 40 can be broken down into 4 times 10. 4 is 2 times 2. Prime numbers there. 10 is 2 times 5. We have a pair of 2's. So square root of 40 is 2 the square root of 10. Another way to think about this, maybe a little bit easier in this case, is square root of 40 is the same thing as the square root of 4 times 10. In other words, the square root of 4 times the square root of 10, and we know the square root of 4 is 2, right? So that might have been a little bit easier to see, just because 4 and 10 are usually easy to spot. All right, anyway. So y equals -8 plus or minus 2 the square root of 10 over 4. Okay, let's simplify that even further. I'm running out of room here. Okay, look at this as 8, 2, and 4. They're all divisible by 2, right? It's one of those special kind of fractions. They're all divisible by 2. So that's -8. Nope. Divide by 2, stupid. Divide by 2. -8 divided by 2 is -4. Plus or minus 2 divided by 2 is 1. So I don't have to write that. That's 1 square root of 10 over 4 divided by 2 is 2. All right, so when you have to enter your answer, you can't type it in, I don't think, as plus or minus. So what you can do is just write it out separately. So what I'm going to say is move that plus out the way. -4 plus the square root of 10 over 2. So see, in this way, I'm able to actually cover both solutions. -4 minus square root of 10 over 2. -4 plus the square root of 10 over 2. All right, that was a long problem, okay? But there was a lot of explanation that went along with that. Let's try another one without all the hand-holding. Maybe it won't be as bad. Okay, so here we go. -16x squared minus 1 is equal to 8x. Okay, and I want to do the same thing here. I can't have it equal to 8x. I need it to equal 0. So I'm going to subtract 8x from both sides, keeping in mind that I don't have any like terms, so I can't combine anything. And notice how I put it between the -16x squared and the -1, right? Because I want my exponents to be decreasing power. All right. A is -16. B is -8. C is -1. X equals -b plus minus square root b squared 4ac over 2a. And then I'm going to go and plug all that in. -b. B is -8. Now notice the negative's already within the 8, so I need to be careful to include it. It's a pretty common mistake that people will start to write negative and then they'll forget the negative that was with the 8, right? Just your hand wrote a negative, so you think you got it. So don't make that mistake, please. Okay, square root of b squared minus 4. A is negative 16. Write that a little neater. C is negative 1. And all of that is over 2 times negative 16. All right. Oof. That's ugly. I keep hitting the wrong button here. All right, so let's clean that up. And notice, by the way, in this example, I didn't do like I did in the last one where I went and I made everything positive, right? You could have done that, and you would have avoided all these negatives. But too late, I've already done it, so we're going to keep going. Negative, negative 8. 2 negatives makes it a positive, right? That's negative 1 times negative 8, if you think about it like that. Positive 8. Plus or minus square root negative 8 squared is a positive 64. All right, negative 4 times negative 6 is going to be a positive 64 times a negative 1 is going to make it a negative 64, right? There are 3 negatives. Again, you can think about it as every pair cancels each other out. Well, that's going to work out nicely, right? Square root of 64 minus 64. 2 times negative 16 is negative 32. All right, square root of 64 minus square root of 64 minus 64 is the square root of 0, which is just 0. So that's really just 8 plus or minus 0. Okay, is there any real reason to write plus or minus 0? Right, think about that. 8 plus 0 is 8. 8 minus 0 is 8. We are literally adding nothing by including that plus or minus 0. So what I'm going to do is leave it off. 8 over negative 32. This is going to work out nicely, right? Because I can simplify that. 8 over negative 32 is negative 1/4. Negative 1/4. Okay, so notice we ended up with only one solution here, right? And in the last example, scrolling up, we ended up with 2 examples, or 2 solutions, right? Okay, think about the discriminant for a second. Notice what happened here. Here, the discriminant, right? That part under the square root. It came out to equal 0. If that happens, you end up with only one real, you'll see the word repeated, solution. Okay, that's going to be a question that you'll see. So keep that in mind. Okay, so what that means is that you got the answer, the solution, negative 1/4, twice technically. Once when you had plus 0 on the 8, and one when you had the minus 0 on the 8. All right, anyway, keep that in mind. We will revisit that later. Another example, and this is my favorite one because it's not the ugliest one, but it might be the ugliest one. All right, so 6y squared minus y plus 2 equals 0. Now, you know this one's going to be bad whenever they start you off with it in the right form, right? They already got it equal to 0 for you, so they're setting you up. So let's do it. A equals 6, B equals negative 1, right? Understood negative 1 here. And C equals 2. So y equals negative b plus or minus the square root of b squared minus 4 times a times c. And all of that is over 2 times a. All right. Well, what does that mean? Negative 1 is a positive 1, plus or minus square root 1 squared, or negative 1 squared is positive 1, minus 4 times 6 is 24, times 2 is 48. 2 times 6 is 12. Okay, and 1 minus 48 is a negative 47. Oh, remember we said that you're not supposed to have a negative under the square root? Okay, that was a big old lie, right? That's That's a lie. Well, it's not too much of a lie because you can technically take that out. Okay, so this is a new idea. You'll see it in college algebra more, but for now, all you really need to know is that if you see a negative under the square root, you can't leave it there. So you need to make it a positive square root of square root of positive 47. But that negative will transfer to the outside of the square root as an I. Okay, I for imaginary. We're going to pretend like this is not real. Actually, we're not pretending. It's actually not real. It's a non-real solutions that we have here. Okay, and so what are those solutions? Y is 1 minus I, the square root of 47 over 12, and 1 plus I, the square root of 47 over 12. Okay, again, we'll get more into that in college algebra, but for now, just understand that I represents the square root of negative 1, and so if you end up with the square root of negative 47, you have to think about that as the square root of negative 1 times the square root of 47, in which case the square root of negative 1 turned into an I. Okay, so that's how you have to think about that. Or not think about it until next semester. For now, again, take the negative, kick it out as an I. All right. So notice, when the discriminant, right, the part under the square root comes out to be negative, we end up with two non-real solutions. All right, so let's really talk about that idea of the discriminant. And that'll be the last thing that we do here. So when I say discriminant, I mean b squared minus 4ac. Okay, and from that, that's the part that's under the square root, right? And from that, I can tell if I'm going to end up with two different real solutions, two non-real solutions, right? Like the previous example. That's when you see I coming in, I for imaginary. And I could end up with one repeated real solution, like whenever we got, was it negative 1/4, I believe? All right, these are my three options. Okay, and it turns out it depends on the discriminant. If the discriminant comes out to be positive, you will end up with two different real solutions, right? Let's scroll up, let's scroll up, let's scroll up right here, right? Our discriminant ended up being positive 40. It was a positive number, and I ended up with two real ugly solutions. Okay, scrolling back down. Scrolling too far. If we ended up with a negative discriminant, we ended up with two non-real solutions. Again, look at the previous example. We ended up with negative 47 as the discriminant. We ended up with two non-real solutions. And then finally, if you end up with 0, right, the number that's not positive or negative, as the discriminant, you end up with one repeated real solution. And the word repeated is kind of tricky here because you don't write two different solutions, right? We ended up with 0 here, and so we ended up with only one solution. Again, you have to think about that as 8 plus 0 over negative 32 and 8 minus 0 over negative 32. So technically, you have two different ways of getting negative 1/4. That's what they mean by that repeated solution. Okay, so that's the discriminant idea. So let's go do two more examples. We're not going to work through these all the way. The only part, or the only thing I'm asking for these, the only thing that I'm going to ask is what kind of solutions I'm going to have. Two different real solutions, two non-real solutions, or one repeated real solution. So the first one, negative x squared minus 6x minus 2. Now again, you may want to save yourself some trouble and make this positive. So divide everything by negative 1. Again, I like that first one to be positive. I don't know. It's just a preference that I have. Okay, it's legal because I did it to everything. All right, so A is 1, B is 6, C is 2. The discriminant is b squared minus 4ac, so 6 squared minus 4 times 1 times 2. That's 36 minus 4 times 1 is 4, times 2 is 8. 36 minus 8, which is going to be 28. And 28 is positive, right? I think so. Last I heard, it's positive. And so since it's positive, I go back up here and I say positive. All right, I have two different real solutions. Two different real solutions. Handwriting's getting worse and worse. Okay, again, because the discriminant is positive, a positive 28. One more. I promise, last one. Oh, last one of the semester, right? Huzzah. All right, negative 6y squared minus 2 equals negative y. It's not in the right form, so let me add y to both sides. Negative 6y squared plus y minus 2 equals 0. I don't like this negative 6 in the front here, although it doesn't matter. I'll go ahead and divide everything by negative 1. Positive 6y squared minus y plus 2 equals 0. In this case, a is 6, b is negative 1, and c is 2. The discriminant, b squared minus 4ac, b squared, negative 1 squared, minus 4a, that's 6, times c, that's 2. That's a positive 1, minus 4 times 6, 24, times 2 is 48. 1 minus 48 is a negative 47. That's a negative 1. Therefore, I would end up with two non-real solutions. All right, well, that was more fun than I expected it to be. I can't think of a good analogy, maybe because all the sugar that I ate or the staying up late at night, or I don't know, whatever it is. But anyway, hopefully that wasn't too terrible. That's the quadratic formula.